So now we're going to do the pipe sizing. Pipe sizing for a supply pipes or supply system. We're going to do the pipe sizing, and these are the things you have to follow. That means these are the rules or the criteria you have to follow to do the pipe sizing. Velocity limitation method, because we're passing the water through a pipe, you have to follow these rules. Branch velocity is 4 fps and stock velocity is 8 fps. Stock velocity means you know the difference between feed main and the stand pipe in firefighting. Same here, stock pipe is the vertical pipe and branch is the horizontal pipe. And pressure drop limitation. Recommend pressure drop is obviously less than psi per 100 feet of pipe. So you have to maintain the pressure drop below 5 psi. Now this is the diagram. We have to do the pipe sizing. So for the pipe sizing here, and take a screenshot for this one. Done. Now we're going to do the pipe size. First of all, picture CWFU and WFU. You have to find out the CWFU. First of all, you have to write down the plumbing features. No need of repetition. Only you have to write water closet, bathtub, shower head, lavatory, laundry tray, and dishwasher and kitchen sink. And no need to again write down the dishwasher. Only one. No need of repetition. And fixtures, write down this one, and the cold water fixture units, write down this here, and the size code as per yesterday. You know the where we can take that from page number 2. We can take that one here from this one, automatic cloth dishwasher and cleaning dishwasher domestic. Here is the water fixtures unit. That one. Then now here is the table. Flow path. Flow path means from the bottom. That means from the farthest branch we have to take the from the starting. We're doing the last. From the last we do. So the flow path is the water flowing to C5 to C4. This pipe segment sizing I'm going to do. This segment base we're going to do the pipe size. C5 to C4. C5 to C4. C5 to C4, that means the pipe size. So here the flow path. CWQ, CWQ, and flow. Pipe size. So the first flow rate, flow path. Flow path is C5 to C4. C5, C5 to C4. And the CWFU, that means the pipe only carrying water for the water closet. No other fixtures, no for any other fixtures that is not carrying the water for that. Only they're carrying for water closet flush tank type. And CWFU for a water closet is here. Water closet CWFU is 5. Yeah, 5. Then the flow rate. Here we can take the individual flow rate. That means only water closet is doing, or you can take from that table page number. Yeah, from the pictures unit 5. So the floor rate is 7. The flow rate is 7. Flow rate GPM. Pictures unit is 5. Then the flow rate is 7. Then we have to find out the pipe size. Now we're going to do the pipe size here. So here the y-axis, for the y-axis, this is the flow rate, and this is the pressure drop. And the vertical lines from the left to right, it's a diameter, and right to left is the velocity. So for here, first of all, I cannot allow more than 5 psi. So here is my flow rate as 7. So flow rate is 7, and the psi, the head loss is 5. So I made that a constant. 5 constant, and 7 is the flow rate. So the line joined here. So that means I need, this is the pipe size, 3 by 4. So 3 by 8, 1 by 2, 3 by 4, 1, 1 and 1 by 4, 1 and 1 by 2, 2. This is the diameter of that pipe. And these are the joints, 7. That means 1, 2, 3, 4, 5, 6, 7. 7 to 5. 5 made as a constant. Because why I take 5 as a constant? Because I cannot take more than 5 at loss. So that's why I make this a constant. 5, 7. So made here. So 7. That means the pipe size is 1 inch. If the point is more than and 1 limit, you have to go for the next. I can't take 3 by 4. That means the point is pointing more than the 3 by 4. So you have to go for the next value. So that means the pipe size is 1 inch. 1 inch. Next flow path. C4, C6 to C5. C6 to C5. C6 to C5. CWV is equal to this pipe segment carrying water for BT and the water closet. So you have to add these two pictures. I already got 5. Now I have to find out the bathtub the unit, the bathroom. So bathtub is 2. Water mixture unit is, so 5 plus 2 is 7. Now I need to find out the flow rate. Page number 7. For a 7 fixture unit, I need 9 GPM. Now it's 9 GPM. Now I need to find out the pipe size. Go to page number 17. Need to find out the 9 is more above 8. So it's a 9 line. 9th line and the 5 head toss. So it seems it's more accurate to 1 inch. So same pipe size needed. 1 inch. So this is how we doing our pipe size. Understood? We can do other things. Next one is C7 to C6, C to C7. Then from here, C2 to C1, C3 to C2, C to C3. Then B to C again, B6 to B5, B7 to B6, B to B7, and B2 to B1, B3 to B2, B4 to B3, B to B4. So these are the this is the kind of path you have to follow. Understood? So this is the idea. So HWQ. You understood or not? Any doubts in this pipe selection? This will took a lot of time to finish this calculation. I think just a pipe size. Understood? Next thing is pump selection. Pump selection. It is an important one. It's an important. That means if you're doing this calculation, you can use it anywhere. No issues. If you're doing for as a normal person or a normal engineer, you have to know this one. Pump selection. That means for a transfer pump, we're going to find out the capacity of a transfer pump, normal pump. That means we have a well, you have an overhead tank or a normal standard tank. I have to fill the water in that tank. I have to suck the water from that well, then fill the water to that my tank, then use to my normal domestic purposes. So these are the basic things. Now we have to do the parameters. So you have to find out the parameters. This is the equation. Wherever you go, you have to follow this equation. The same equation we done it in firefighting to find out the HP of my pump. Same. And BHP, brake horsepower or motor horsepower. That means MHP, motor horsepower or the metric horsepower, whatever. Total dynamic head loss, that's in feet of water column. The unit is an important one. It's in water column, or hourly we get in the PSI or whatever. We have to convert into water column. And the flow rates. Flow rate in GPM, gallons per minute. And 3960, it's a constant. And efficiency. What do you mean by efficiency? There is no such thing as efficient as 100%. So our motor has a limitations. So the pump has a limitation. So we will take as a 0.85 as efficiency. Normally we took 0.75 or you can take it as a 0.85. No problem. Now we need to find out the pressure loss. So means, what do you mean by head loss? The head loss means HP plus HB plus HS plus HF. HP means pressure head. HV means velocity head. HS means static head. HF means frictional head. We want to find out the head loss. You have to find out all of these values. Then add it together. You will get the total dynamic head loss. Now, first one, pressure head. What do you mean by pressure head? Actually, these are the concepts you have to find out, not the answers actually. What do you mean by pressure head? How many sides have a pump? If a pump have how many sides? How many sides? Two. One is suction and one is discharge. As a normal pump, our overhead tank does not demand any kind of pressure over there. So you don't have to worry about that pressure head actually. This pump will work on our atmospheric pressure. If the overhead tank demand the pressure, then only you have to find out the pressure head. For a normal pump, as a transfer pump, you don't need to worry about that pressure head. Actually, we did it in our firefighting. Why we find out the pressure head in over there? Do you have any idea about that? Pressure head. Why we took a lot of time to find out that one. Why we find out the pressure head? Have a firefighting pump. Why I need to find out the pressure head? To maintain pressure, exactly. Because everything, that means sprinklers, hydrants, everything is demanding the pressure. They need a minimum pressure for their work. That's why I have to find out the pressure head. Normally here, they took as an example, UGT is in 60 psi and OHT in 80 psi. So you have to minus that one. HOHT minus HUGT, that is equal to pressure head. Actually, there is no need of this one. Pressure head obviously at 0 for a transfer pump. That means our overhead tank doesn't demand any kind of pressure. Now we have to move on our static head. What do you mean by static head? If I have to find out where I am going to find out the static head? On a horizontal pipe or a static pipe? Where I have to find out the static head? Where I have to find out the static head? No. Yes. Rather against vertical pipe. On a vertical pipe. Amal, why did you say that OHT? Why I have to find out the pressure, the static head in OHT? What idea leads to that answer? Static head. Got confused here. Now we have that. Static head we only find out in our pipes. Because pipe carrying the water. So you have to find out the pressure drop happening. The head means the loss, the resistance. The water will face the resistance in our pipe. That loss I'm going to find out. According to that pressure drop, I will buy that pump to eliminate that pressure, pressure drops. That can cover the pressure drop. That's why I have to find out the resistance. Understood or no? You're okay with my answer? Amal? So here. So this is the water level they are showing. Actually, here they took the pipe. The vertical pipe length is 100 feet. Length is 100. But the water level, why they minus 20? Actually, the water level is 20 feet. Do you know what I mean by water level? If the water is filled like this, obviously the water will come in this pipe for the 20th level. One second. That's why they minus 20. So that is the static. Because if the water is below than 100 feet, that means the pipe started from here and then connected here. Then the pipe length is 100 feet. Then you can do 100 feet as a static head. This is a concept you can take 100 feet. No problem. So the static head is 100 feet or 80 feet. Is fine. Now come to that velocity head. You understand this one or not? The water obviously filled with the same level as in a pipe. We know the water level. Water level. Water level. You know that. If I filled the water in this tank, then I connected a pipe. Then I took as a vertical. The water will show the same level. Basically, placement of the suction bag. Yes. Yeah. Placement of the suction bag. Yes. Obviously. Then I have. Then I have the. Then I have one velocity head. Velocity head have a equation v square by 2g, and v square means the velocity. I split it in two: suction and the discharge. Have two sides, right? And one more thing. So the stock velocity is 8 of PS. Here I am dealing with the stock pipe. Here I am dealing with the stock pipe. Obviously, I have to take the velocity as 8 FPS. So the suction is the same and the discharge is the same. So suction 8 and the discharge is 8. Then the gravity is 9.8 meter per second square. Now I have to convert it into feet per second square. That's why I got 32.2. When you do this one, you will get 2 feet of water column. And remember this one, obviously velocity head will be below than 2 feet of water column in any ways. Below than 2 feet. And the frictional head. Frictional head has something we have. Frictional head. The sum of all head losses due to the friction occurring the straight pipes, fittings, and accessories. We know what kind of accessory we have in plumbings. Just use the Google. See, it's right. Yes. Which are the accessories they are saying? T joint, L joint, reducer. This is the main mistake everyone. I said, what are the accessories, not the fittings? That is, there is a difference between fitting and accessories. You said these are the fittings, elbow, reducer, T joints, everything are the fittings. What are the accessories? Accessories, pipe accessories. Do you remain this valves, butterfly valves, strainers, non-return valve? Idea? Idea. The valves are the accessories. The strainers and the valves are the accessories. So that's the difference between fitting and accessories. Pipes is not an accessory. Pipe are the straight pipe. That's like a kind of frictions over there. Obviously, fitting and accessories are different. Rahul, you understand? Not understood? 5 psi. So I have to maintain 5 psi, the 100 feet of pipe. I can take the flow rate. See, here they took the instant ones. I will give one thing so, for a change. Flow rate. Flow rate down. OHT capacity. Capacity is capacity 15,000 gallon. Fill up time. Fill up time. Obviously, I will give 30 minutes, 45 minutes. Whatever. Could you find out the flow rate for me? Flow rate. We have the idea. We will easily find out. OHT capacity is 15,000 gallons and the fill up time is 14 minutes. So you can find out the flow rate happening in that pipe. Stuck? Need help? How did you find out that one? What is gallons per? What is flow rate? Yes, it is. What is flow rate? GPM. What that means? Gallons per minute, right? Gallons per simple thing. You have to divide. Gallons is 15,000 divided by 45. You will get that answer. So that is the one they got. Understood or not? Here is the answer. Understood? So you can easily find out this one. You can set up the fill up time. According to that fill up time, the capacity of pump will change. That is the idea. Easy, right? So you can give this idea. These are the basic things. Okay. Understood or not, everyone? Okay. Don't go for the setup things. These are the setup things. I will give the flow rate as a 50 GPM. Somehow they find out someday overhead tank capacity and they took the fill up time. So go for this one, no problem. So that thing you have to carry that. Okay. Remember that one. Flow rate 50 GPM. And now I have to find out my HP and here, here. Once again, and the horizontal pipe. You have to contain first of all the horizontal pipes. Pipe plus means the horizontal pipes. Horizontal pipe is because the vertical pipe we took as a static loss. That's why I have to take horizontal pipes. I need to know what is the length of that horizontal pipes. Oh, where did they give that one? I assume 10 into 10. Here I have 10 feet and here I have 10 feet. The total is 20 feet. 20 feet. For a 20 feet pipe, I already told you. Here's a happening 5 psi per 100 feet of pipe. Per 100 feet, the 5 psi will happen. Then how to find out for the psi for the 20 feet? How to find out? Divide 5 divided by 5 divided by 2. Understood or not? Understood or not? Yes. So for 100 psi, it's 20 feet. It's a 1 psi. It's happening in now. I have to find out the loss happening in fittings. Fittings. What are the fittings I have? 2 elbows. Nothing else is here. 2 elbows. Now, search here. Now, before that one, we have to find out the pipe size. So 50 GPM and 5 nanometers. 50 GPM and 5 nanometers. So this is the point. That means 2-inch pipe. 2-inch pipe. For a 2-inch pipe, what is the size of your elbow? For a 2-inch pipe, what will be the size of your elbow? For a 2-inch pipe. If the plumber asks, buy the 2 elbows for the 2-inch pipe, we go to the shop. What the size you going to? What size you going to buy? 2 feet. So 2 inches. Obviously, it is 2 inches. Obviously, it has 2 inches. 2-inch pipe. So I'm going to find out 2-inch elbow length. And please, no. My tables are gone. That's why I have to. Ten inches. In 5 feet. In my opinion. Yes. It's okay. Do you have that HVAC table? What about that? Do you have the HVAC table? Does anyone have that table? These are the from when that's not a comes. There's a different types of tables. That's why. Do you have any tables of HVAC? I think it's a 5 feet. Which is 5. So you have to find out first drop happening in that one. By 5 divided by 100 and multiplied into 5, then multiplied into 2. You will get 0.5 0.5 psi happen over there. Then you have to find out the strainers and NRVs and total equal length and the frictional losses. So I put that table. That's why I'm using these things. Strainers and NRV total equal length and losses. PSIs. Then you have to convert into. When all things are in a PSI, you have to convert into water column. Then you will get the HS, HV, HP, and HF. HS, the static head. Static head, obviously, the length of that vertical pipe. Then HP, the velocity head, obviously lesser than 2 feet of water column. And HP, pressure head, obviously 0. And HF, the frictional head. Frictional head means the friction by that accessories and the horizontal pipes and the fittings that causes the frictional head. You have to find out that one, then put that value here. Then the flow rate. Using this one, this could be more useful for you guys. That's the GPM. Then I will share the notes like the hydraulic analysis. I share the same note for this one, this calculation, component calculation for you. Then these are the BHP find out. Then using the driving losses, you will get the capacity of HP. So these are the basic idea for pump head. I will share the notes of that one, how to find out the flow rate. So okay, I'm missing that tables. That's why, including the tables, I will send you. So, so you okay? Any doubts in this one? Any doubts? The particle dot. Any doubts? Doubts in this one? Okay. So then we have the one more sections remaining. That is for the drainage. We'll talk to drainage tomorrow. So tomorrow we go get these sections. So any other things you need? Do you have anything to suggest? Any topics? Any other topics you need? Have anything? Anything you have? Guys, am I still audible? Yes. Any Naina, do you have any doubts? Seems you are a doubtful guy. I know. Any doubts you have? The pump room sections will be that will create in your rivet sections. We'll clear that thing. This is three-dimensional drawing. Any other? So now, no doubts, right? So good night. See you tomorrow.